Good afternoon. Today we are going to discuss about transactional concept in database management system. Transactional concepts in DBMS, that is database management system. First of all, what is transaction? What is transaction? Transaction is nothing but a program unit whose execution may change the database. So program unit in the sense it contains sequence of operations. Sequence of operations. So after executing the transaction or after executing the sequence of operations may change the database. How it will change the database means, let us consider our bank database. In our bank database, for example, if you are transferring the amount from one account to another account, it will change the database. That means it contains several operations. First we will open the account. After that, amount will be debited from the particular account. Then it will be credited to the next account. So this is the sequence of operations. These sequence of operations are represented as transaction T. So if you change after executing this sequence of operations or transaction, the database will change. So even the database will change, the database should maintain the consistent state. Consistent state. Consistent state means correct values. Correct values. After executing the transaction, we should maintain the database in consistent state, that is the correct values. So consistency means, let us see one example. To consider the account A, another one account B, account having the amount 300, account B having the amount 400. Suppose we are transferring the particular amount, that is for example 100 rupees, we are transferring from account A to account B. So what will we do? First of all, we will open the account. For that we have to write the instruction read A. First we are opening the account A. After that, we will debit the 100 rupees from account A to from account A. So A is equal to A minus 100. That is 100 rupees subtracted from the account A. Then the remaining amount will be stored in A. So after that we will store the account details. So we will write the instruction write A. At the same time, in account B, this 100 rupees will be credited. So how will we write the sequence of operations or set of instructions? First we will open the account B. After that we will credit the amount. So B plus 100 is equal to B. So then you will store the account B. So you will write the instruction write B. So now the A's amount is 200, B's amount is 500. So this is the sequence of operation. We will consider this is a transaction T. It contains sequence of operations. After executing this transaction, it will produce the output, that is after execution A plus B is equal to 700. That is A's amount 200, B's amount 500. So 700. Before execution, also A plus B is equal to 700. That is A's amount 300 plus B's amount 400. So total is equal to 700. So before executing the transaction and also after executing the transaction, the total amount is 700. This is the consistent data or consistent database. So even if you perform any updates in our database, you should maintain the consistency or consistent database. So what we will do to make our database consistent database? So for that the database system follows some properties. The properties are atomicity, so to make our database system consistent database system, we are using the property acid property. Acid properties. Acid means A for atomicity. C stands for consistency. I means isolation. D stands for durability. Atomicity, consistency, isolation and durability. First of all, atomicity. So atomicity means, for example, if you are doing any transaction, for example, we are transferring the amount from one account to another account. This is the first account, this is second account. We are transferring the amount from this account to this account. The entire process should be completed, otherwise not at all. So the entire process means, normally we are transferring the amount means from the first account to information debited, that is amount will be debited. After that it will be credited. If suppose debited but it not credited to the next account means the process is not completed. Due to some problem, there is network issue, any problem, amount will not be credited. So this is the inconsistency. So transferring the amount from one account to another account means the full process amount, if we debited the amount, it should also be credited to the next account. Otherwise it will produce the inconsistent data. So to avoid that, we are following this atomicity property in our database system. Second one, consistency. Already I said that consistency means correct values. We should maintain correct values in our database after executing the transaction. So to maintain the correct database, consistency means we should maintain our database with the correct values. So correct values, before executing the transaction, we have the amount 600. After executing the transaction also should be 600. This is the consistent data. Suppose if there is any variation, that is, for example, you have debited the account, you have to consider the account A, this is account B. This account has the amount 10,000 rupees. I have debited the amount 2,000 rupees. So if it is debited, here the balance should be updated 8,000. So suppose if it is not updated, it is not a consistent database. So next, to maintain the consistent database, we are using this consistency property. Next, isolation. Next property, isolation. So isolation means in our database, we should execute the transaction in isolated manner or separated manner. For example, multiple users accessing the same database means at the same time inconsistency may be occur. For example, consider two transactions T1 and T2. So in this transaction, we have the value x equal to 500, y is equal to 500. So here also x equal to 500, y is equal to 500. We are going to perform operations on x. So first we will read x value. After that we are calculating x equal to x into 100. Then we will write or store the x value. So write x. Next we will read the next value y. Here also we are doing some operation, that is y is equal to y minus 50. So in this operation, here we are multiplying x with 100. So we will get 50,000. Here y value is 500. So we will get 450. At the same time, transaction T will be executed. That is multiple users accessing the same database. So So read the same x value. After that, they are reading y value. Next, they are calculating z is equal to x plus y. Here, it will read the x data 500. But we have updated the x value from 500 to 50,000. But it will read 500. So this is the inconsistent data. But actually, should read the updated value only, but it will read the initial data. So for that purpose only, we are executing multiple transactions at the same time. We should maintain the consistent database. Even if the database change, should maintain the consistency. So for that purpose, we are using the isolation property. So last one, durability. So durability means, for example, to consider the same example, in our ATM, we are withdrawing the particular amount. After withdrawal, it should be updated. Already I said that the example, in our account, we have the balance 10,000. We have withdrawn the amount 2,000. So remaining balance should be updated in our existing database 8,000. If it is not updated, it is inconsistent data. So at the correct time, the database should be updated. This is known as durability. If it is not updated, it will produce the inconsistency. So to execute a transaction or multiple transaction, we should follow these asset properties. So this is transaction. Thank you.